Hi guys, today we're going to talk about gases. Gases are something that are all around you. We're going to be talking about various aspects, including gas laws. So up first, you guys know what you're supposed to do. You're going to be copying down the stuff that is in bold. So you have heard about gases. You've talked about states of matter before. So just to make clear, you know what we're talking about. Gases are made up of particles. So it could be molecules or individual atoms that when they're in this state of matter, they don't have a definite shape or volume. So they take the shape of whatever container that they're in. They have the volume of whatever container that they're in. Gases are compressible, which means that the amount of empty space between them can change. So you can change the volume of gas by making the volume of the container that they're in smaller. So a couple of properties that you need to be aware of when talking about gases. It is assumed that gas particles are small. You know that all atoms are small and all molecules are small. So this should make pretty much sense to you. They're going to spread out to fill up whatever container they're in. So that container could be your soda bottle that you drank for lunch, or it could be the entire classroom that you're in or the entire room that you're in. They'll spread out as far as possible. They are compressible, meaning that you can force those particles to be closer together, or if you give them more space, they can be spread out too. So compressing is when you actually make the area or the volume they're in smaller. You're compressing them down, you're making that volume smaller. We're going to assume that there's no attractive or repulsive forces between those particles either. So if they hit into each other, they're just going to bounce off each other, like you can see in the animation that's on the right-hand side of the screen. We're also going to assume that gases move rapidly in constant random motion. So gases are going to be the fastest moving particles out of the three states of matter that you're most familiar with, which are solids, liquids, and gases. They're going to have random motion, and they're just going to bounce off of each other. So if they hit into each other, they're just going to be like, okay, and bounce and go into opposite directions. Here's just a couple more ways to represent how gas particles behave. You can see on the image all the way on the left that this represents gases in a balloon. They're moving around randomly. You can see they hit into the sides of the wall. They bounce right back off. They can hit into each other, bounce right back off. Same thing is going on the right-hand side image. Now this time they're in the cube, so they'll take whatever shape of a container that they're in. And then you see what happens when the shape of the container is changed with the image on the bottom. So we can see there's two different types of particles in here. And when that container is opened, they're able to flow out. So they're taking the shape and expanding to the volume of whatever container they are in. So at first, they're in the closed box. The box is open. They then move out and take the shape of the new box that they're in. And here's just a little comparison for you of the different states of matter that was mentioned before. So we have the solid. You can see the particles in the ice cubes are really packed tightly together. There is some movement there, but definitely not that much. In a liquid, we have some more movement going on. The particles are able to slide past one another. And in gas, you see that the particles are much more spread apart and that there's more motion going on. You can tell there's more motion going on because those arrows indicating motion are longer than that in a liquid. So there are ways to predict how these random particles that we mentioned before behave, and gas laws are used to do that. So gas laws, they do have a mathematical component, but don't be afraid. The math that goes along with gas laws really isn't that bad. So we're going to go through and talk about each of the things that affect how gases behave first. I want you to copy this chart into your note section. This chart, we're going to go through three different properties that affect how gases behave, which include pressure, volume, and temperature. As we go through and I'm talk about each of them, I want you to write the property down, include the unit that we'll be using when we do gas law problems for that type, and then how it actually affects the gases. So what is the relationship between that property and how it relates to gases? Pressure is up first. So the actual definition of pressure is the amount of force exerted on a given area. This probably makes sense. You've probably heard of pressure before. Maybe you even felt like you're under a lot of pressure to perform well in school before, but its mathematical definition, including you can calculate force, is how much force you're putting on a certain area. When we are dealing with pressure, we're going to be using either atmospheres, which is abbreviated ATM, or kilopascals, which is a lowercase k, a capital P, and then a lowercase a. When you're dealing with pressure, and especially when it comes to doing gas law problems, you just need to make sure that if the original problem is in atmospheres, that your answer should also be in atmospheres. And that if you're working with 2 units of pressure, they need to be in the same unit. So if you're working with atmospheres, it has to stay in atmospheres. If you're working with kilopascals, it has to stay in kilopascals. And it should make sense that the more particles that you put in a container, the higher the pressure will be. So think about it as if you're blowing up a balloon. The more air that you're putting into that balloon, so you're blowing the balloon up, you're blowing the balloon up, you're blowing the balloon up, the more particles you're putting into that balloon, and eventually the pressure is going to become too great on the sides of that balloon, and it's going to burst. Volume is up next. So we talked about volume way in the beginning of the school year. We know that volume is the amount of space that an object takes up. For gases, we're going to be using the unit of the liter. Remember, if you need to make conversions, you can. There's 1,000 milliliters in 1 liter, or there's 1,000 liters in 1 kiloliter. Remember to use your staircase steps if you need to. And then because of the gas particles spreading up to fill up whatever container they're in, the volume of the gas is the same as the volume of the container that they're in. So really easy, no real math there. You just have to be aware of what volume you're dealing with, and that's the volume of the gas. And then temperature. So this is also kind of going back to the beginning of the school year. We know that temperature is a measure of how hot something is. And when you're dealing with gas laws, your temperature units have to be in Kelvin. So normally we'll see in science class temperature given as degrees Celsius. And it's really easy to convert between Celsius to Kelvin. You're just going to add 273 to that Celsius number. So Kelvin are the units that we're going to use for all of our gas law problems. And if in the problem it gives you the temperature in Celsius, just remember to convert it. And what is the relationship between gases and temperature? The hotter it is, the faster those particles of a gas are moving, which also means they're exerting a greater force on the walls of whatever the object is that they're in. So greater force, we know, means more pressure. So higher temperature, higher amount of pressure too. All right, so just a little practice to convert to Kelvin. Take a second, convert each of these units or each of these temperatures to Kelvin. Hopefully you got the right answers and we can move on.